Hello everybody. Today I'm going to introduce about the tomology. It's actually made up this name. And it's about applying calculus on physics. Many times you will find yourself it's hard to write the calculus sentences, but if you use this method, it will become somehow easier. So actually at first, I don't think this method is the first. I'm the first one to use this method. So if you have seen this method before, please tell me what's its proper name. And also, this method is actually inspired when I was trying to solve a two-dimensional calculus problem. And I used it on a one-dimensional situation, and I found it really useful. So I would like to share this method with you. So how do I formalize this kind of method? I try to prove that with a similar thoughts in summing up the discrete things. So in the discrete situation, let's imagine you have a lot of apples here. Those are a lot of apples, and each of them have a different mass. For example, they have 3, 2, 2, 1, 4, 2, 3. They're just imaginary. There isn't an apple that has 3 kilograms. So if I want to know the sum of the mass of all of the apples, what do? I will point at the first apple and I add it. I write down 3. I point at the second apple, I write plus 2. I point at the third apple, I write plus 2. And on and on and on. If I point at the fourth apple, I will write plus 1. So let's reevaluate what we are doing here. So when I point at the fourth apple, I will write down the equation of 3 plus 2 plus 2 plus 1. So what is the difference between these two? Well, what is the actually meaning of the first one and the second sentence? The first sentence is actually saying the mass of the 3 apples is actually equal to 3 plus 2 plus 2. And the second sentence says that the first 4 apples, the mass of them is equal to 3 plus 2 plus 2 plus 1. So what is the difference between those two sentences? It's 1, the mass of the fourth apple. So I think this is a little bit interesting because what we get here is something like this. The added element is the difference between the difference of the summoning method function. Let's call it f. Here, the summoning method function is the first couple of apples, and the difference of the thing is delta f, which is the element that we added recently, which is the fourth apple in this situation. So let's see whether we can use this kind of thought. Here is a really classic example. You have a circle plate which has the charge density sigma of r, which is equal to sigma 0 times 1 minus small r divided by big R. Big R is the radius of the whole plate. It means that at the point which has the radius of small r, you will have the charge density of sigma r. So I want to ask you, what is the total charge of this plate? So if you study physics, you will know that Q is actually equal to the integral from 0 to r, the charge density sigma r times ds, which is the area with the radius of r. So here is a question: what is ds actually? You may already know that ds is equal to 2 pi r times dr. And that actually makes sense. But right here, I can use another method, which called the tomology, and I will show you how. This is much more, I think, is a little bit easier, and you can do it without making a mistake. So let's consider what is the summoning method function here. How do we sum all of them up? We sum it from 0 to r, big R. So what we are trying to do is to first calculate the center, and then we add a small circle around it, and another small circle, and another small circle, and so on and so forth. And finally, we will add all of them up in turning into the whole plate. So let's consider what do we do when we are adding the rth circle. It has the radius of r, and what we already added is every part that inside the circle of radius r. That is, when we are adding r, what we already added of the area is pi r squared. So what do we add when we are at the radius of r? I mean the step when we are adding the radius of r. ds is actually equal to the derivative of the right side, which is 2 pi r times dr. So we know what this ds is, and we get exactly the same result. By inserting this one, we will know that the total charge will be Q is equal to sigma from 0 to r times sigma r is sigma 0 y minus r divided by big R times ds, which is 2 pi r times dr. And this is actually a mathematical question, and it's a little bit simple, and I will not discuss it here. So we solve it by the Tomology. Let's see another example whether we can use this method. So we have a water trough of the shape of a prism. This question is from Inga, 2021. And now the water trough is full of water with depths of 0.6 meter. Let's call it H, big H. So we want to know the forces exerted by water on the triangular end of the trough. So let's consider the property of the fluid. We know that for the fluid, it has the same pressure exerted on every direction, and the pressure is actually equal to rho times g times h. So this is another calculus question. We want to know the force. Force is equal to, if we integrate, I would like to integrate it from the bottom to the top because I think that looks simpler. So it is from 0 to h times the pressure at the depth h times ds. Again, what is ds? So if I calculate it from the bottom to the top, because it is a right-angled isosceles triangle, so it has the same length of x. What I already added, I want to write the function of the summing method function. So the area I already added, s of x is equal to 1 over 2 of x squared. So what is ds? ds is the area that I've added recently. That is, ds of x is the derivative of the right side, which is x times dx. Therefore, by inserting this one, we know that the forces is actually equal to integral from 0 to h. This depth h is actually equal to h minus x. So it is rho times g times h minus x times ds. ds is x times dx. So now it's a mathematical question again. We can solve it easily. Last but not least, I would like to discuss a little bit about the 2D scenario, because I came up with this idea in this kind of scenario. It is elective because you will not encounter it, I think, during your K-12 education. But if you are interested in the two-dimensional calculus well, you're probably going to like this. So how do we solve a two-dimensional calculus question? So let's move on to let's go back to the discrete scenario again. So I put a pseudo code here. If you know coding, it's easy for you to understand what it's talking about. So at first, in that Apple example, we only have one iteration that from the left to the right. But in a 2D scenario, we have two iterators. One is from the left to the right, adding from the left to the right, and the other is from the top to the bottom. We will add all of the sum in this square. So we can actually implement Tomology in a 2D scenario. Let's consider if I have a plate. The plate has the charge density sigma of theta and r, which means at the point of theta and r, it will have a charge density of theta r. So I want to know the total charge of this plate. You will write a calculus sentence soon, quickly, which is Q is equal to the integral from 0 to r. I will add it by a circle first, from a point to a circle and the circle and the circle around. And then I will integrate it by 0 to 2 pi, because in every different angle, the sum is different. So when I'm adding at radius r, I will add theta in a clockwise way. So it will be the double integral, the sigma of theta r times partial squared of s. So what is the partial squared of s here? Let's consider the summing method function again. So what we are summing is from the center to the outside layers. And then in each layer, we add it in a clockwise way. So what we are doing when adding at the angle of theta and radius r. So as theta r is actually the area of this one, a sector with radius of r and the angle of theta. Because when we are trying to add theta a little bit, what we are doing is exactly adding the next term, which is the next term in a clockwise way. And when we add r a little bit, this is what we exactly want. So the area of this sector is equal to pi r squared times theta over 2 pi, right? So it is theta times r squared divided by 2. So what is the partial squared of s? We know that partial s with respect to r is equal to theta times r partial r. And again, partial squared of s with respect to theta is actually equal to r times partial r partial theta. Therefore, we can insert this one. My pen is not working. Okay, we can insert this one. So after inserting this one, we know that charge is equal to sum from 0 to r, sum from 0 to 2 pi, sigma theta r times partial r times partial theta. So this is another mathematical question. So I will leave you here. And that's all for our Tomology. Thank you for listening.